Okay, can I step it up? Can we try something harder? Looking around, most people I think have got it. It's not that difficult. Actually, that's sort of more like a warm up. For this is the real kind of question. Okay, so how's it different? How's it the same? It's the same in that I'm still after a specific coefficient. Okay, but it's different in that now I'm considering a product of two binomials. Gross. Okay. Now, by the way, that's part of why these numbers are not as huge. Okay, but the process is going to be similar with a little bit of complexity added on. Okay. So before I start writing this thing out, okay, I'm still going to start off in much the same way. I am going to have to write an expansion out, but the difference is this time I am actually going to need every term of the expansion to see enough of the pattern. Okay. Now I'm going to call this one my red expansion, and I'm going to call this one my green one because they're going to get really confusing really fast in a second. Okay. So let's start by actually doing the expansion. This one to the power of 4, this one to the power of 3. Okay, let's do the red one first, right? Nice big square brackets, and every bit of the of each term we should include, right? So the first term, its binomial coefficient will be just 4 choose 0, right? And then how much do I have of each of these terms? Well, I'm going to have 4 of the first one, and I'm going to have none of the second one. Right? Okay, so far so good. Now, next term along, everything increments up or down accordingly. Okay, is this the right one? Yeah, that's plus. Okay, so just watch out in a second. I am going to get the minus sign for later on, but for now I don't need to worry about it. Okay, then 4 choose 2. 4 choose 3. And my last one, 4 choose 4. Oops, sorry, skipped the number. Okay, is that all right? So it's the power of 4, that's why there are 5 terms. So far so good. But that's multiplied by this other expansion, which has less terms, but it's still kind of gross. Big square brackets, it's the power of 3, so the row of Pascal's triangle I'm in is the third row, right? So 3 choose 0, x to the 3, and this time I got the minus sign, so include it, okay? Minus 1 on x, I've got no lots of it in the first term, okay? Then it keeps going. 3 choose 2, and the last one. Okie dokie. Now, in order to see what's going on here, and see what's actually going to be useful to me to work out what the coefficient of that term is, let's just do a little bit of simplifying here. Get rid of some of the, you've got these different x terms which actually interact with each other, okay? So, the first one, and for choose 0, actually anything choose 0, and anything choose itself, we know that's equal to 1, okay? So I'm going to start to drop that off, try and tidy this up a little bit. My first term will be x to the 4, right? Then I'll have 4 choose 1. Now I've got 3 lots of x, and then I've got to divide by x once, right? So my actual power up here will be x to the 2. Yep. Next one, 4 choose 2. And the x squared and the 1 over x squared cancel out exactly, okay? So it's just 4 choose 2. Right, now 4 choose 3. How many have I got of those? Well, I've got 1 lot of x, and then I have to divide by 3 lots of x. So I've got 1 over x squared. And then my last term over here, 1 over x to the 4. Okay, so it does start to look a little bit neater once you get down to it. Down here again, 3 choose 0, that's just 1. X cubed, no lots of this, so that's what I've got there. Okay. Next one over, 3 choose 1. Now, watch out for your signs, okay? I've got an x squared, and then I have to divide by an x, and I also have this minus sign, right? So what am I going to get? That's minus 1 over x, right? Is that okay? Yes? Wait, sorry, no. Wrong way. Minus x. I'm ahead of myself. Okay, so the next term. 3 choose 2. Here, this is what I meant. So I've got 1 lot of x, and then I'm dividing by 2. But that minus 1, it squares, so it's a positive, and I've got 1 over x. That's better. Okay, last one along. 3 choose 3 is just 1. And I've got no lots of this, and that minus 1 is going to go 3 times, so I'm going to end up with a negative. So I've got minus 1 over x cubed. Okay, we got there. Right. Now, what am I after? I want the coefficient of x, okay? Now, when you multiply out, right, you're going to get a whole bunch of terms. In fact, you're going to get, well, I've got 5 terms here and 4 terms here, so I will get 20 terms out at the end, and then I have to do some simplifying, okay? But out of those 20, which ones would I be interested in, right? Only the ones that give me a single x at the end, okay? So for instance, if I take this x to the 4, it will only produce an x when it matches up with one specific term out of the green series, right? Which term does it need to match up with? Yeah, the very last one over here, yeah? So they sort of have to link up, okay? In the same way, this x squared term here, what does it have to match up to get an x? Well, it's going to have to match up to this one and only this one, right? So this x squared and this 1 over x, they're going to connect as well. Okay. Now this is just a constant. Okay. So which one will it match up to? Where it has an x over here, you can actually see it's just going one at a time, right? So this nothing is going to line up with here, and this 1 over x squared, you can follow the pattern, is going to link up to that x cubed. Okay. Now at this stage, even though I've got one leftover term here, it's 1 over x to the 4, right? There's no term in the green series that it could match up with to get an x, right? Because what would it need? It would need an x to the 5, wouldn't it? Which I don't have, okay? So therefore, now that I've got these 1, 2, 3, 4 paired terms, I'm after just the coefficient, okay? So the coefficient of x will be equal to, now, just to help us one little bit more so that next time you don't have to have all these numbers of crazy arrows flying around, right? I can generalize this a little better by calling this, say, let's call all of the terms here, you know, term n, okay? And we'll call this one, well, I can't call it t, so I'll call it the next letter along. I'll call them u, m, all right? So what have I got? This x to the 4, right? Depending on the way that you write it, I'm going to call it term 0, right? Or its coefficient, rather. It has to line up with 0, 1, 2, 3, right? So that's u3. Yep, those two have to, they're going to multiply out. Then I move over 1 here, and here I move 1 back, right? So this will be term 1 and then u2, yes? Term 2, u1, term 3, sorry, have I missed one? No, it's okay. u0. And I'm out of terms. That's it. Okay. There are my 1, 2, 3, 4 pairs. Okay. So now that I've identified them, I just want the numbers for each one. Okay. So here I've got 1 and minus 1. Here I'm going to have 4 choose 1, and what does it line up to? 3 choose 2, right? Next one along, term 2. That's up here. So 4 choose 2, and that lines up with 3 choose 1. And don't forget, it also has a minus sign there. Hi. From that minus there. Okay, so watch out for that. And lastly, 4 choose 3, 3 choose 0, which was just 1, actually. We already knew that. Okay. So now I can evaluate that, which I've already written down. So there's the coefficient at the end, okay? So you can see, this was a little more, work. Actually, it's a fair bit more work trying to line up the terms. But once you see what's going on, and that you're moving forward here and backward here, that allows you to produce this thing. Can you see how orderly the coefficients are? And they just build quite, in quite a structured way, okay? So it's quite predictable.